In this lecture, we are going to start working on the attack behavior of the enemy. For now, we have a sequence node here, which is the patrol node. Then under it, we have the patrol task and the wait task. The enemy is going to keep walking until it needs to turn around. Then the enemy will wait and keep going. Now we can start working on the attack behavior. For the enemy to know when to attack, we need to have a player as a local variable in the behavior tree. In the behavior tree, we manage the local variables in a place called blackboard. You can see the blackboard in the upper right corner, but for now it's grayed out. So let's create a new blackboard by clicking on this button. I'm going to keep the file in the AI folder under the BP folder. Let's call it enemy blackboard data. Alright, now we can switch to the blackboard. In the blackboard, we store data in the form of keys. Let's click here to add a new key. Let's select Object. This is going to be the player in the world. Let's name it Target Player. Let's go to the right side to define the class of this key. Expand key type. For the base class, let's search and select our BP player. Alright, now we have a key called Target Player, and the base class is BP Player. Next, let's add the attack behavior to the behavior tree. Switch back to the behavior tree. The setup here is going to be a little bit complicated. I'll try my best to explain as we go. First, let's disconnect the patrol node from the root node. Then we drag out from the root node to add a new node. This time, we use a selector. The selector is somewhat similar to the sequence. It can have a bunch of children under it, and it executes the children from left to right, just like the sequence node. But if you read the information here, you'll notice the biggest difference is the selector is going to stop when one of its children succeeds. This is exactly opposite from the sequence. I'll explain why we need the selector here instead of the sequence. For now, let's just keep going. Let me move the patrol node and the nodes under it to the right side. Then we connect the selector to the patrol node. Right-click on the patrol node. Select Add Decorator. This is going to add a decorator node to the patrol node, and the decorator node decides if this patrol node is going to run based on the condition. Here we want the condition to be a blackboard key, so let's select blackboard. Select the decorator node. Let's rename it to No Valid Target Player. This is the condition that we want to use to trigger the patrol node. We want to check if the player is close up. If the player is closed up, then we set it as the target player. Otherwise, the target player is not going to be valid. And in this case, we just want the enemy to patrol. Let's set the blackboard key to target player. Then let's set key query to is not set, meaning we only want to run the patrol node when the player target is not set. Alright, next. For the notify observer above, this is set to unresolved change, which means this decorator is going to run whenever the value of the target player changes. This is what we want, so we do not need to change this setting. Next, we have observer aborts. Let's set it to self. This means whenever the target player becomes valid, this patrol sequence is going to abort, so the patrol behavior of the enemy is going to stop. Alright, now you can see the green color that highlights all of the nodes that are going to abort when the player target becomes valid. Next, let's drag out from the selector again and create another sequence node here. Let's rename this node Attack. Notice that the attack node is to the left of the patrol node. This is very important and you should have the same order here. Then let's add a blackboard decorator to the attack node. Let's rename the decorator to valid target player. And this is the condition that we want to run the attack node. Select target player as the blackboard key. And we don't need to change the rest of the settings, especially for the observer aborts. It has to be none, because when the enemy is attacking, we don't want the attack action to be interrupted if the player runs away from the enemy. Also, the key query is set to is set. So the attack sequence is going to be triggered when the target player becomes valid. Next, let's drag out from the attack node. Add a wait task. Change the wait time to 1 second. Alright, that's it for now. I know we haven't set up the actual attack task, but I want to test the game now to show you why we need the selector node rather than the sequence node. You can see under the selector node, the attack node is always failing, but the patrol node to the right still gets to run. This is why we use the selector node. Alright, let's stop the simulation. Let me give you a quick demo on why the sequence node won't work in this case. And you don't need to follow what I'm about to do. This is just to show you the difference between the two nodes. Let me create a sequence node from the root node. I make the attack node and the patrol node its children. Now let's see what is going to happen when we simulate the game. Let's select the enemy to the left. And you can see here nothing happens in this behavior tree because the target player is invalid for now, so the attack node is always failing. In this case, the patrol node to the right never gets to run because when one of the children fails, the entire sequence stops. You can try to put the patrol node to the left. You might think this is going to work. Indeed, now the patrol node is working. But the attack node to the right is never going to run, even when the target player becomes valid. Because when the target player becomes valid, the patrol node is going to fail, and the entire sequence stops. Alright, that's the quick demo. Let me move everything back to place. Remove the sequence node and reconnect the selector node. Alright, I think this is the graph before the demo. So let me simulate the game again to make sure everything is still working as before. Seems like everything is alright. Before we start working on the attack task, we need to give the enemy the ability to detect the player. So let's jump over to the enemy BP. Make sure you're in the viewport because we are going to add a box collision as a detector for the player. Hit the Add button, then search for box collision. I'm going to rename it Player Detector Box. When the player enters this box, we want the enemy to attack. I want to narrow the box, so let's reduce the X value of box extent to 22. Then we want to put the box ahead of the enemy. Let's set the X location to 44. We can go to the 2D view here. It makes it easier for us to see where the box is. This is pretty much the size and the location of the box that I want. We can also increase the line thickness. Let me set it to 0.5. This is going to make it easier for us to see the box in the game. You can also change the color of the box. The property is called shape color. Let me just set the box to a green color, maybe, because I want to differentiate from the other collision shapes in the game. Let's go back to the level and simulate the game. Unfortunately, the box is not showing up in the simulation, but you can press Alt plus C to toggle the collision. And this is going to allow you to see the box. But this only works in the simulation. When you play the game in the viewport, you press Alt plus C to try to toggle, and the box is not going to show up this time. So if you want to see the box in the game, like for debugging, then there is an option you want to enable. Let's go to the enemy blueprint. Select the player detector box. Let's search for hidden in-game. Disable it. Now you should be able to see the box when you play the game in the viewport. Alright, let's leave it this way, because for now, it's nice to visualize the box. Next, we need to set up the collision preset for the box, because we only want this box to pick up the player. Stop the game and go back to the enemy blueprint. Select the player detector box and scroll down to the collision section. Let's expand collision presets. To make the box only interact with the player, we can set presets to the custom mode. Then we have the ability to change the individual settings, but I don't want to handle it this way. I prefer to create a new preset. So let's go to Edit, Project Settings. Go to Collision under Engine. This time, we do not need to create a new channel. All we need is just a new preset. So let's click on the New button. I'm going to call the preset Player Detector. For the Collision Enabled option, we want to choose Query Only, because we don't need any physics for the box, since it doesn't need to interact with any physical objects. It only needs to detect the player when the player is inside of the area of the box. Next, for the object type, let's set it to World Dynamic. Then I'm going to set Ignore for all channels. This way, the box is not going to react to anything. But we need to change the player channel to Overlap so we can actually detect the player. Alright, let's hit Accept. We have our player detector preset here. Let's go back and set the collision presets, but we don't see the new preset here. So let's compile the blueprint first. Then we should be able to see it in the list. Good, now the presets for the box is set to player detector, and the options are automatically applied. Next, we need to update the target player key in the blackboard when the player enters the box. Switch to the event graph. Let's add the onComponent begin overlap event. We also want to add another event. This is for when the player leaves the area of the box. So let's add this onComponent and overlap event. Alright, next we need the blackboard. We can get it from the controller of the enemy. So let's call the getController function. Then we call the getBlackboard function on it. To update the target player, we can call the setValueAsObject function on the blackboard. Let's connect the beginOverlap event to this function. We also need to tell this function the name of the key. Let's drag out from the key name input. Let's promote this to a variable. I'm going to name it keyname underscore target player. Alright, now we need to figure out the actual name of the key in the blackboard. I mean, we know what it's called, but I just want to double check. Go back to the blackboard in the behavior tree. The name is target player. I'm going to copy this name and go back and paste it into the variable here. Alright, the last thing is to set the object value, which should be our player in the world. We can drag out from the other actor of the event. This should be the player, then connect it to the object value. Let me read out a little bit. Alright, now we have set the target player in the blackboard when the player enters the detector box. Don't forget that when the player is out of the box, we need to clean the value of the target player. So let's drag out from this getBlackboard node. We call the clearValue function. Then we connect the endOverlap event to it. This function is going to set the target player to invalid. Don't forget to connect the keyname. Alright, we're all set here. Let's compile and go back to the level to test. Let me undock the behavior tree window so we can see what's going on as the game runs. We want the player to be involved this time, so we are going to play, not simulate. Let me try to select the enemy that's right next to the player. Alright, now this is the behavior tree of the enemy that's right next to the player. We can see the attack node is constantly running. Then the enemy go back to patrolling when the player is out of its detector box. When the player comes back and gets inside the detector box, this enemy stops again, because now what we do in the attack node is just waiting. Let me run away and come back again, so you can see what's happening in the behavior tree. So far so good, and we should wrap up this lecture. But don't forget to save everything. I'm also going to comment out the notes we just added in the enemy blueprint.